Okay, hey guys, the next set of graphing topics are coming in smaller videos, but with more problems. So here's what I want you to think about. As you're taking notes, I might do 3 problems for one type of problem because these are starting to get to be a little bit harder and you will need more practice with them. Okay, so when I'm looking at your notes, I'm expecting to at least see 2 problems. You don't have to do the third one if you feel like you got it. But never, ever, ever just be like in a hurry. The point is to learn. So I recommend that you do watch me do the first one, attempt to do the second one, and try for sure to do the third one if you can't. If you didn't do the second one, try to do the third one. I'm intentionally doing more because we are headed into a quadratic unit and you are going to become quadratic factoring beasts. You are going to become graphing, like able to graph whatever. Okay, so, and let me start again. So, like, if you're given, let me go ahead and get my glasses on. Um, so, the idea is that by the end of this chapter, if you see something like this, you have an idea, like you will immediately go, oh, it's quadratic, which means it's got a U shape and it's positive, so it's going to go up. And I can find where it crosses the x-axis by doing this, by ABC. And I know where the y-axis is by doing whatever. I know that's a really bad y-axis. I'll take that off. Okay, let's say it goes like this. Oh, goodness. Okay, there. I can find the axis of symmetry. I know what the max, I know what the min is. You're going to know all these pieces, parts, and you're going to be able to graph it. Okay. Um, the point is to learn. I'm giving you a lot of problems to do it. Take what you need. Do not rush it. Okay. I want to go over to here and let you know that this is standard form. Okay. We are going to be learning 3 different forms for quadratics, and you have to know how to go from one form to the next. Okay, so this is standard form, and you could also put a y here. That would be fine. F of x, we're in function notation because we're growing up mathematically. Okay, there is also vertex form. You know what? Let me do this in a different color just because it's a different form. So it'd be prettier. Okay, this is vertex form. That is where you have a times x minus h squared plus k. This is vertex form. And I guess I could have put, for standard form, I could have put f of x equals ax squared plus bx plus c. Okay? And then this is vertex form. So an example of an equation in vertex form would be f of x equals 2, maybe -2 times x minus 3 squared minus 2. And from here, you would know that the vertex is 3, -2. You know it goes down. You know it's steeper. I mean, there's a lot that you can just pull just by looking at the numbers. It's almost like a magic trick. It's kind of cool, you guys. You are just going to become beasts. All right, here we go. And the last form is called intercept form. I'm going to do g of x just to change it up. And this one looks like this: a times x minus p times x minus q. And it is called intercept form. Okay, so an example of that would be like -3 times x plus 2, x minus 4. And then you would know it crosses the x-axis at -2 and 4. You know it goes down. You know it's steeper. There's a lot of things you know, again, with this form. Now, to go from here, to go from here to here, okay, we're going to learn how to do that. Basically, you're going to be factoring it out. See? Factoring it. Okay? To go from here, oops, Let me do this. Let me grab black to go from black, black, black. Okay, to go from here to here is actually going to become a quiz for you guys. This is called completing the square to go this direction. Completing the square. And that will be a quiz, and it'll be an extensive quiz. It's one that you have to start with standard form. You need to complete the square. You need to graph it, and it's all a method. All right. To go back this way is just multiplication. It's really simple to go from here to there. It's multiplication both ways. All right, moving on. I just wanted to give you those forms. Those are really important. Make sure you have them down so you kind of understand at least that there's 3 different forms. You will learn what they mean as we go along, but for right now, that's what we're doing. Okay, here we go. Hello. Come on. Here we go. All right. I'm going back to here. Okay, so I'm actually going to cut off the camera. I just kind of wanted to go with you in the beginning. Okay, and now I'm going to cut myself off so you don't have to see me. All right, here we go. All right, it says use the graph of the parabola to fill in the table. So does the parabola go upward or downward? And I don't want you to forget what we learned in good, I hope this is recording, Desmos. Okay, when we learned Desmos, remember we were plugging in y is equal to like 2x squared, okay? I don't want you to forget what you learned. If you need to, go back and play, because then you can see like, oh wait, what happens if I change this to a negative? Oh yeah, it flips it down, okay? What happens if this becomes a fraction? Oh, it opens it up. So you can kind of understand what happens if I add, a 7. Oops, let's not try adding a 7. Let's try adding a 4. It moves it up, okay? What happens when I play with it in vertex form? So x minus 2 squared plus 3. All right, look. The vertex is at positive 2, 3. Like you can play with it on Desmos. I highly recommend that you play so that you kind of understand what an equation does. Okay. Going back to my notes. Here we go. All right. Hang on a second. Okay, sorry about that. My daughter had to call me and show me her cat that was wet. She gave her a bath. All right. So here we go. Okay, it says finding the vertex, intercepts, and axis of symmetry from the graph. Okay, so here is the graph. Okay, very simply, I'm not going to spend time on the simple questions. It says, does it move upward or downward? Obviously up. Find the axis of symmetry. So the axis of symmetry is the imaginary line that goes, we always do it with the dotted line. I can't really do dotted lines very well with this thing, but it is the line that is right smack in the middle, that if you folded the parabola over, it would fold on itself. This is x is equal to 4. And so that's what you would write, x is equal to 4. Remember, x is a vertical line because you drop your x. Okay. Find the coordinates of the vertex. 4, 0. These are pretty simple, right? Find the intercepts. The intercepts are where they cross the x-axis. If there are more than one, separate them with commas, and if none, none. So, sorry about that. That was crazy. Let's try that. Let's try going back. Sorry, I don't know. I moved my thing. Okay, here we go. All right, so 4, 0 here. All right, so intercepts. Take a look. 8 is the y-intercept. So I think when it says y-intercept, I think you probably would just write 8. I don't know that they would want you to put 0, 8. That's an option. In this case, there's only one x-intercept. It happens to be the vertex. Okay, and that is 4, 0 or 4. I think it might just have you put the number. The x-intercept is just the the y value and the x value. Okay, let's try the next one. Okay, graphing a parabola. Now you need to write down the steps to graph a parabola because they are, oh, never mind. This is in vertex form. So you still need to write down the steps, but this is not the negative b over 2a1. This is the vertex form. So remember, this is y equals a times x minus h plus k. So step one is to graph the vertex. Okay, you pull it out of the equation. Okay. Step two is to find 2 points on either side of the vertex. And then 3 is to reflect them over the axis of symmetry. And that's it. It's pretty simple. It's not that hard. So the vertex, remember, the minus sign is part of the equation. This is a plus. The only way you could get a plus inside there is if it was an x minus -3. Get it? Because that would be a plus. So we always take the opposite of whatever's in here, and this is perfectly fine. So the vertex in this case is -3, -4. So you graph that, -3, -4, that's your point, okay? Then you graph your axis of symmetry. I guess I should have put that here. I'm gonna put that as 1a. Sorry about that. Let's do this, okay. 1a. When you forget, just add an A. Okay. Draw axis of symmetry. Okay. Draw the axis of symmetry. So I'm going to draw that now. And it always goes right through the vertex. That's what it does. Okay. Graph the vertex axis of symmetry. Now it doesn't make you do this, but I'm just doing this because this is standard. Like if you get in a math class, it's going to ask you to do this. So it's good for you to know how to do it. Okay, it says 2 points to the left and 2 points to the right. What you do is you are going to draw. Okay. Oh my goodness. You are going to draw or graph a couple points to the left or to the right. I could plug in a -4 or a -5, right? Because those are the 2 points to the left. Or I could graph a -2, -1, which is what I'm going to do. Okay. You pick the 2 points to the right or to the left. Now you need to plug it in. Now you can do this by hand or you could do it in a calculator. It doesn't matter to me. I do it by hand because I happen to be much faster by hand. Okay, so 2 times x, x is -2, -2 plus 3 squared minus 4. Okay, so we're going to we plugged in -2, -2 plus 3 is 1, 1 squared is 1. Okay, so you get 2 times 1 minus 4, which is a -2. So we're going to put -2. -2, -2, right there. Okay, then we're going to plug in a -1. So you come here and you erase this or you write it again. It doesn't matter. Nobody's judging you. I don't care. I typically would actually write it. So we're going to plug in a -1 now. -1 plus 3 is 2. If you want to write out your work, you could. 2 squared is going to be 4. 2 times 4 is 8, minus 4 is 4. So -1, 4 is right here. Then you want to reflect it to the other side. So it took you 2 to get to the axis of symmetry. So go over there and there. And then you're going to connect it. And luckily, Alex does this for you. You don't have to try to do it like me. Oh my God. Okay, you get the idea. Let's try this again. I'm sorry, you guys. I will attempt to do this. I have a drawing pad. It's a really expensive, fancy drawing pad, but I'm just not that coordinated yet. Okay, here we go. Boom. All right. So that was the first problem. graphing this. I do have another problem. Okay, so pause it if you want to try to graph it on your own and try to find the critical points. Okay, let's see. So here is the vertex is -4, -1. Okay, and then you graph that -4, -1. Okay, graph your axis of symmetry. I like graphing it in a different color because it makes it more fun. Plus, you don't think it's part of the graph. It's not, it's an imaginary line. Most of the time, they make you name it. By the way, it's x equals -4. Okay, by the way, before we begin, check this. This is going to go cup down. It's negative, just so you have an idea of which direction we're going. I probably shouldn't have written the name of the line there. I should have written it on the other side. That's why I checked it, because I realized, oh, what if? Oh my God, come on, eraser. Come here. There you go. All right, so here we go. Now we're going to go back to blue. I'm going to graph a couple of points. So x, y. I'm going to pick two to the, I always go lower because lower is easier to manage. So x, y, -3, -2. I'm going to plug in a -3. The easiest way to do that is simply write it first without plugging anything in, and then just doing it right below it. -3, then plug in your x, okay? Squared minus 1. Y is equal to -3 times 1 squared minus 1. Y is equal to -3 minus 1, and it equals -4. Okay, then let's do another point. I'll do it in a different color just because we're going to plug in a -2. Okay, now you could go back here and erase, but I don't want to. That's too much work. So y equals -3 times -2 plus 4 squared minus 1. -3 times 2 squared minus 1. -3 times 4 minus 1. -12 minus 1 is -13. Okay, and let's see if this makes actual sense. So let's go -3, -4. That makes sense, right? Okay, and then we're going to go -2, -13, which is way down here. Okay, and then we're going to reflect it to the other side, and then way down here. Okay, then you connect it. My favorite thing about Alex is the connection that it does. Wow. Okay, you get the idea. I just can't redeem myself with that, okay? All right, so that's graphing in vertex form. Vertex form's kind of nice because they give you 1 point. Okay, the next thing is completing the square. Completing the square is a method of, it's going to be a method of solving or changing from standard form to vertex form. But completing the square is simply asking you, what number would you plug in so that you could factor this like this? Okay, remember we had a squared plus 2ab plus b squared, and that equaled a plus b quantity squared. You may or may not remember this. You may have absorbed it, but the whole point is that we are looking for b squared. What in the heck would that be? So the way you do it is you take the middle number here and you divide it by 2, and then you square it. Okay, so you take b divided by 2, and then square it. That is how you get to that value. So 4 divided by 2 is 2, squared is 4. So the answer here is 4. Okay, so this would have been x plus 2 quantity squared. They're not asking for this, but I guarantee you that's the only reason why you're learning it, is to be able to understand how to go from here to here. Okay, but right now it's super easy. They're just asking you, okay, complete the square. So you go 12 divided by 2 squared. Okay, 12 divided by 2 is 6. 6 squared is 36. And that's what goes right here. And if you were to factor it, you guys, you would get y plus 6 quantity squared. Okay. I'm not going to explain where they get the name of completing the square, but I guess just real quick, what it is describing is a square with the same side, x plus 2, x plus 2. And you're trying to figure out what that last number is. All right, it's super simple, but you need to write this down as a note. Okay, you have to, and a lot of times people don't remember it. So you kind of have to have it in your repertoire. Okay, next. All right, graph the parabola. So to graph the parabola, ready? You've got to know how to you got to know the steps. Okay, first step is find the vertex. Okay, this is given to you in standard form. Notice that. So you have to find the vertex. That's the most critical point, or at least the most helpful point in a parabola. So finding the vertex. How? Okay, remember the vertex is hk. Okay, well, h is equal to negative b over 2a. So remember this is y equals a, and put the a there for some reason, ax squared plus bx plus c. Okay, in this case, and sometimes it's helpful to name it. A is equal to 1, B is equal to negative 6, and C is equal to 13. Do you see how I got that? You pull it out from underneath. They're the coefficients and the constant. All we care about is B. Okay, it says take the opposite of B. Do you see how B is negative? Well, this would be negative of negative 6 over 2 times A, which is 1. So that would be 6 over 2 or 3. What this is the x value of the vertex. So how do you find y? Okay, to find y, you plug it in. Plug it back in. Okay, so we're going to go y equals, and we're going to plug in the 3. 3. Well, let me write it first so you understand. Okay. Y equals x squared. Let's write it. X squared minus 6x plus 13. Okay. So now we're going to plug in that 3. So we're going to write, and I'm going to go ahead and change colors. Y is equal to 3 squared minus 6 times 3 plus 13. Y is equal to 9 minus 18 plus 13. You are welcome to do this in a calculator. Just make sure you put parentheses in your calculator around the number. It doesn't matter if it's positive, but it does if it's negative. Okay, and then y is equal to 9 minus 18 is negative 9 plus 13 is 4. So your vertex is 3, 4. And you graph it. 1, 2, 3, 1, 2, 3, 4. Draw your axis of symmetry so you have the idea of what it is. You can make a good habit of labeling your axis of symmetry. This thing is going to go up, so I'm going to label it on the bottom. It's x equals 3. All right, and then we're going to pick 2 points. It's the same thing. Pick 2 points. Points, reflect. I'm not going to write the whole thing again because I already wrote it once, and it's the same. Okay, so now we're going to plug it in, and we're going to plug in, let's plug in 2 and 1. Okay, so if you make your t-chart, x, y, we are going to plug in 1 and 2, or 2 and 1. I'll put 2 and 1. Okay, so let me show you how to plug it in to a calculator. Because, okay, let's go with Desmos. So with Desmos, actually, you guys, if you don't want the graphing calculator, you put scientific calculator. And I believe you get it. Do I or do I not? Do I have to have no spaces? Sorry. They have a really great, nope. Okay, sorry. I didn't do this right. Let's try this again. Desmos.com. They have a really nice scientific calculator. So here it is. Oh, it's scientific. Okay, there you go. Desmos.com scientific. check it out. So to put it in there, you would go x squared minus 6x plus 13. So plugging in a 2. So we go 2 squared minus 6 times 2 minus 13. Did I do that right? Oops, no, I didn't. 2 squared. 2 squared, hello, minus 6 times. I thought I put times. What the heck? Okay, do you see how I wrote that? Let me make sure I made it right. 2 squared minus 6 times 2 minus 13. 2 squared minus 6. Okay, good. Okay, it's kind of fun is because look, you get the answer is negative 21 right here. Okay, and then you can just come back and plug in the 1, right? If it's negative, make sure you put parentheses. But you could come back and just be like, okay, let me plug in a 1. Boom. And now you get the answer is negative 18. Wow, that is not fun. Okay, so obviously I would think on, wait, I didn't do that right. Oh, it's plus 13. No wonder. Makes sense, you guys. Here we go. Plus 13. All right, 8. 1 is 8. Okay, 1 is 8. I'm going to plug it back in. 2. See how nice it is on a calculator? You could just change your values. So it's 2518. Okay, so I don't typically use the calculator, but hey, if you like it. 2. No, my dear. Oh my God, you guys, today is just not my day. Actually, it's not that bad of a day. Geez, I act like I'm like suffering so much. Okay, so it's 22518, right, you guys? So 25 is right here. 18 is right here. Reflect it to the other side, and you are good to go. Connect it with a smooth curve. Do not make a point. My kid had a teacher that would take off if it wasn't a smooth enough curve. All right, there you go. Simple enough. Okay. Now this one is for you to try. Okay. If you want to pause it and do it, that would be great. Okay, I'm just going to do it now. Okay, for the vertex, negative b over 2a. So this is step 1, right? Okay, so it's helpful to list a is 1, b is negative 2, and c is negative 2. Okay, opposite of b is 2 over 2 times 1, which is 1. So x equals 1. This is h, remember? That's what we're solving for. And then we plug it back in. So y equals 1 squared minus 2 times 1 minus 2. 1 minus 2 is negative 3. Okay, so our vertex is 1, negative 3. Let's check which direction this thing goes. It goes cup up. Ooh, cup up. Okay, so 1, negative 3. That's our vertex. Okay, we know the axis of symmetry is coming down here. The name of the axis of symmetry is x is equal to. All right, I'm going to plug in the 2 points to the left because I like 0 a lot. I love 0. It's my favorite number to plug in, and negative 1. Okay, you always want to go in the same direction, you guys, because if you pick 0 and 2, they're going to have the same value. So then you'll have to pick negative 1 or something, okay? All right, let's plug it in. Y equals 0 squared minus 2 times 0 minus 2. These cancel out, and you just get negative 2. That's why I love 0. Then, look, it's negative. I put it in parentheses. That way you don't screw up. Negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2. Minus 2, so the answer is 1. All right, so you get 0, negative 2. This thing is going down. Oh, no, it's not. Sorry, I didn't see the vertex there. I lost it. Okay, and negative 1, 1. There we go. Reflect it over. And then hopefully you guys did that well and didn't need my help with that, okay? Get the idea? Boom. There we go. Next. All right. Here's the third one. You can skip this one if you want, okay? If you need it, try to do it and then see if you did it correctly, okay? First is h, is negative b over 2a, which is negative 8 over 2, which is negative 4. Then we're going to plug it in. Y equals negative 4 squared plus 8 times negative 4 plus 21 equals 16 minus 32 plus 21. 21 and 16 is 37 minus 32 is 5. Okay, so the vertex is negative 4, 5. Here we go. Negative 4, 5. Make a line, make a point. All right, now we got the axis of symmetry. We want to go to the left or to the right. I'm going to go with negative 3. Wow, it's okay. Negative 3, negative 2. Okay, and we are going to plug it in, x squared plus 8x plus 21. And I'm actually going to go here, x squared plus 8x plus 21. I'm going to go, okay, x squared, so I have negative 3 squared plus 8 times negative 3. This is how you would plug it in, okay? Plus 1, I don't remember what it was. Let me go back. I have no memory. Plus 21, x squared plus 8x plus 21. 8x plus 21. Do you see what I did? There we go. Okay, and the answer is 6. I plugged in a negative 3 and I got 6. I'm going to plug in a negative 2 now. So all I have to do is change this. You could plug in whatever you wanted, right? Like any number of points. You could just keep plugging them in. So that's 9. What was negative 3 again? I forgot. Negative 2 is 9. Negative 3 is 6. Okay, here we go. Negative 9. Yeah. Okay, so 6, it's going up. Okay, and negative 2, 9. There we go. I reflect it. You are welcome to plug in those points. And this is kind of a weird, steepy kind of thing. All right, next. Okay, now you are now changing. Okay, the difference is now we have a value for A. It is the exact same process. They act like it's different, but it is a little different because you have to multiply now. Okay, did they have the last one? No. Okay, so A, I'm going to change colors just to change it up a little. A equals negative 2, B equals negative 12, and C equals negative 17. I know we don't use C, but right now, but we will eventually. Okay, so H is equal to the opposite of B over 2 times A. So it's 12 over negative 4, which is negative 3. Okay, I skipped the step of multiplying it. Now I'm going to plug it in. Y equals negative 2 times negative 3 squared. You could still do this in the calculator if you wanted to. I just am not because I suck at remembering what I just wrote. Okay, plus 36 plus minus 17. Okay, and then this is negative 18 plus 36 minus 17. These two together make 35. The answer is 1. So the vertex is negative 3, 1, right here. Okay, and I should write that. The vertex is negative 3, 1. Vertex. Okay. All right. Axis of symmetry, same steps we used before. Check and see if it goes up or down. It's going to be going up down because it's negative, so it's going to be going like this. So I'm going to write the name of my axis of symmetry up on the top. All right, now we need to plug in 2 points. I'm going to pick 2, negative 1, x, y, negative 2, negative 1. Okay, I'm just going to do it right here, do it in a different color. Y, hello, y equals negative 2 times negative 2 squared minus 12 times negative 2 minus 17. Okay, negative 2 times 4, that's positive 4, plus 24 minus 17. And this becomes negative 8 plus 24 minus 17, and 24 minus 8 is 16, minus 17 is negative 1. Okay, and then I'm going to be lazy and I'm going to come back in here and I'm going to erase things. Okay, so come here. Wait, why'd you do that? Why? I still haven't figured out how my arm moves things. It's really weird. Okay, there we go. This is not good practice, but I thought I ran out of room and I realized I didn't. I could have just shrunk the stupid thing down. Sorry about that. Here we go. Okay, so there we go. We're here. So I'm going to plug in a -1, -1. I'm going to get 1. I'm going to get a -2. I'm going to get a positive 12, 12. -2 plus 12 is positive 10, minus is -7. Okay, so we have -2, that's one ugly -2, -2, -1, okay, and -1, -7 down here, okay? And then we're just going to reflect it like we keep doing. It's the same process. If you can plug in a couple points, you're good to go. If you guys wanted to, you could literally just plug in also the other 2 points on the other side if you didn't feel like reflecting or if reflecting is hard. You could always just use your calculator and plug it in. Next. Okay, same thing. In this case, see, I didn't do that, y'all. I'm so sorry. You know what? Here, let me just do this. Get back here. Okay. All right. Hey, if nothing else, notes are fun because now they go all over the place. All right, let me grab blue. Okay, I'm just going to find the vertex in this case to help you out. Ready? So vertex H is equal to negative of -8 over 2 times -2. Make sure you know how to plug it in. A is -2, B is -8, C is -13. Okay. That means 8 over -4 equals -2. Plug it in. Y equals -2 times -2 squared minus 8 times -2 minus 13. Sorry about that. All right, equals -2. Be careful. Make sure you're paying attention to signs on these. Okay? -8 plus 16 minus 13. That's 8 minus 13 is -5. And that's your vertex. -2, -5 here. Okay, and then you'll notice it's going to go down. Ooh, so I probably can't graph it here anyway, but I would pick the 2 points to plug in my T chart. I would pick -1 and 0. Oops, I'll put -0 and -1. If I plug in 0, you guys, you can just see that it's going to be -13. Okay, and I can't go there. I don't have space. I don't think I do anyway. Let me see. Can I move it up? Oh, it's not that bad. Okay, and if I plug in the -1, can we do that really quick? I'll just do that really quick. So -2, y equals -2 times -1 squared minus 8 times -1 minus 13. -2 times 1 plus 8 minus 13, that's -5, minus 2 is -7. Okay, so -1, -7. You can reflect it. I didn't do the axis of symmetry. And then you get -13 down here. Okay, yeah, whatever. Ooh, and then connect the dots. All right, next. Okay. Actually, you know what? I'm going to leave this because I feel like I've done enough. I've done too many. I'm going to go on to the next one, which, okay, that is the last one. No, maybe it isn't. Hang on. That's it. Okay, for these notes.